My name is Will Shulman. I'm the CEO and co-founder of MongoLab, which is a MongoDB hosting provider. And I'm actually going to show you guys some of that towards the end of the presentation. But basically what I want to talk to you guys about today is using MongoDB for building backends for your mobile apps. Hopefully I won't catch hell for this. I gave the same talk at iPhone meetup recently, and so this is an iPhone, but I put an Android phone further back in the deck to try to redeem myself. But basically, I think probably a lot of you folks have been in a situation before where, you've built your mobile app and you really want to add some features or have some functionality that requires you to have some information off device or have some server-side component to it. While there certainly are applications that exist in a vacuum, like a calculator. I think most modern apps you see are not going to be like that. Anything from just wanting to store user profile data, logging. Obviously with mobile, location-based data collection is really important. Game data, polls, surveys. These are just examples, but really, it could be anything. But your backend could be Facebook, right, or Twitter. The point is, this is a real problem. And I think what most folks start to think about when they're writing a mobile app and they start to think about what they have to do to have a server-side component, they obviously think about how they're going to host this, and hopefully most people don't host it themselves and use some sort of cloud service. They think about the platform that they're going to use to write the server-side component, which is mostly going to be probably a REST API to sit between a MySQL database and the rest of the world. And so you say, okay, I'm going to use Rails. Do I want to use J2EE? And the general approach usually looks something like this. And I'm sure that many of you out here have done something like this in the past, where you pick for yourself some sort of cloud provider like EC2 or Rackspace, and there's other cool things like Google App Engine and EngineYard and Heroku. Some of these platforms now that are actually more than just an operating system, which are becoming really interesting. They combine a lot of these things together. But then you go ahead and you pick your data store technology, and you most likely pick something like MySQL. You go about building a REST API for your. This is my Android phone. So you basically implement a REST API so that your phone can talk to your backend, and while it might get a little bit more elaborate than this. This is the general approach. But one thing I want to try to explore with you guys is how can we do better than this, right? And in my opinion, one way to do better than this is to kick out your MySQL and put in MongoDB, and I'll show you the reasons why in a minute. How many people here are familiar with MongoDB in any way, shape, or form? Okay, so just maybe a third of the group, which is cool. So MongoDB, this is 10gen, the company behind MongoDB, describe it as a scalable, open source, high performance, document-oriented database, which is a mouthful. And hopefully that'll, all those terms will make sense in a minute. But basically, I like to call it, the database your database could smell like. The Old Spice guy. No one seen this commercial? All right, that was my joke for today. So when I describe MongoDB to folks, the way I try to describe it, or why it came into being, for the most part, to solve two big problems, right? One problem is what folks in the industry call the object relational impedance mismatch. And actually there's a whole industry around this, right? The whole object relational mapping industry is an industry designed to solve this problem. The problem of, in your programming language, you want to think about things like objects. You want to think about things with fields or properties, and those values are, maybe they're strings, maybe they're dates, but maybe they're other objects or arrays, and it's this nice nested data structure stuff. Relational databases aren't like that, so whenever you save data to a relational database, you have to do this mapping, and it's a pain. The other problem that MongoDB set out to solve from its very inception is the horizontal scalability problem. So any of you who have tried to get MySQL to scale past what, or not just MySQL, right? Any of these guys, past what it was originally designed to handle, find it hard. I mean, you go into techniques, you implement sharding, right? You might divide your data set into lots of different sub-pieces and route in your application the requests for the data to the appropriate place for it. But basically, scaling to the size so that you can implement something like Twitter or YouTube or any of these types of things is really difficult with traditional technologies. And so these guys set out from the get-go to try to solve that. And I'll talk about some of the ways they did that further in. One quick thing I just want to talk about is how do I connect to MongoDB? They basically went the approach of implementing a driver in every language. So it's kind of like JDBC. So if you're in Java or Python or Ruby, there's a package from MongoDB that you use to connect to it. It's a binary protocol, really fast, really tight. Enough on that. Okay, so for those who are not familiar with MongoDB, the general mapping of terminology I like to give is that, they both have the idea of a database. But in MongoDB, the term collection is what you use to describe something that's like a table, and you'll see in a minute how they differ. And then the term document or object is what in the relational world is a row. So this is a document. I actually think that sometimes people get confused when they hear that. They think like PDF file or something, but really it's a JSON object. MongoDB at the end of the day is a really, really awesome JSON object store. And so this is an example of the type of object you might store in MongoDB. I picked the example of a blog post. You've got the ID, you've got an author. Notice that values can be, they can be numbers. They can also be nested objects, right? So here the author is not just a name, but it's a name and an email. There's the post, the date. One cool thing I'll talk about later, and one of the reasons why MongoDB is really good for mobile, is you can store latitude and longitude coordinates and search by them. It's built in. It's very cool. Rating, you can have arrays, right? Just everyone's familiar with JSON, right? And the cool thing about MongoDB, they like to call it schemaless, because you can just, at any time, add fields to objects and rock and roll. A lot of folks use the term a schemaless database. Doesn't mean your data doesn't have structure. It doesn't mean your data doesn't have a schema to it, right? In fact, if you look at almost any collection in a Mongo database, you'll look at the stuff and you'll see everything has an author, everything has a post. Right? There is a schema to it. It's more implicit. So it's the kind of thing where the database doesn't enforce the schema. And so, the term schemaless database is thrown around, but I just want to clarify, like, your data does have structure, your data does have a schema to it if you wanted to. It's just that the database doesn't force you to declare it ahead of time and do all sorts of hokey pokey to, set it up for new fields you might want to put into a particular object. But let me show you guys how to search on this stuff. So anyway, query language, super dynamic query language. Basically, you can search by any field in your collection, right? So for example, if I want to search all the posts where the author's name is Mike, and notice you can do the dot notation thing, and you can do it all day long, as deeply as you need to. You can search for ratings less than 2. Remember that tags was not just a primitive, tags was an array. But you can say things like, I want to find all posts that have software as one of the tags. And it's smart enough to know that tags is not a scalar, that tags is an array, and to do the right thing. Here's an example of finding the most recent 10 posts. So they have a built-in idea of limiting and skipping, helps with pagination, helps with stuff like that. You can do sort order, all that kind of good stuff. There's obviously much more than this, but I'm just kind of giving you a flavor and a taste of it. They also have the notion of atomic kind of update operators, and this is actually getting to what we were talking about before the presentation. If you had a new comment you wanted to add to a particular blog post, you can actually specify to MongoDB that you'd like to update the post and you'd like to push this new comment onto the list of comments, and you'd like it to be done atomically, meaning if you have thousands and thousands of concurrent posts going on, you don't have to worry about dropping one of them. This is just one of the atomic operators that MongoDB supports. It's like putting something onto a list, adding a property, removing a field, basically everything you could want, or mostly everything you could want. It doesn't support multiple operations in a transaction, and I'll talk a little about in a minute, but atomic operators it does support. There's support for doing cool aggregations. It has MapReduce built in. I don't want to really go into MapReduce, but basically, for those of you who are familiar with it in other technologies, it does support the idea of a MapReduce system. Like I mentioned earlier, they definitely thought about the whole scalability and performance thing early on. This is kind of the classic magic quadrant diagram, but if you think about your traditional database over here, it has some horizontal scalability problems, but it's very rich in functionality. You have the full power of relational algebra at your disposal. It's very mathematically complete. You can really do almost anything you want to. Over here, you have something like memcache, which is in memory, blazing fast. Traditional key value stores, which aren't quite as expressive as full-on JSON object, right? So this is where MongoDB sits. I think it's a pretty good spot. The two things that they have that allow for the really easy creation of clusters are the idea of replication. So they have built into the architecture the idea of master-slave replication, also the idea of replica sets, where you have 5 databases that are all meant to be replicas of each other and keeping them in sync. They also have the concept of auto-sharding, whereby you can specify, hey, I've got this huge data set, and I want it to be split across a number of nodes, and I would like to partition the data set. Let's say it's a huge collection of usernames. 500 million users, for example, which some sites have now, right? Like Bitly and things like that. You'd be able to say, okay, let's take the last name of the user and use that as a partition key, and you can set up 100 nodes, and it will keep them all balanced. And if they run out of room, it will repartition them, and it's actually really, really cool. It's a deep topic, so I'm not going to go into it too much here, but they have a nice picture of it. I stole this from the MongoDB website. And basically the idea is, you as a client can interface with a single MongoDB, or you can interface with a very robust and distributed cluster of them, and it looks just the same, and it's very cool. Yes, so the question is, what is a replica set? And I'll explain here, actually. The idea of a replica set is a set of MongoDB instances that to the outside world behave as one, but basically provide for 2 things. One is, because there's lots of them, in a situation where you're doing reads only, and you only care about, you don't care if reads are a little bit what's called eventually consistent, meaning if something's writing to it, you might be 10 seconds behind to get the new data. So it helps you scale out in terms of read scalability. You can have a whole bunch of replicas of a data set, and they'll all be synchronized with the master, and it spreads out the reads so that the reads can be, get more throughput by spreading it out amongst lots of nodes. Other thing it does is provide failover. So you can put a bullet in one of these guys, and the replica set knows the other members of the set and will reroute traffic to the other ones and figure it all out and do the right stuff. Besides this being really good for the web domain, I think it's also really good for the mobile web domain, right? First of all, everything's in JSON. I don't know if you noticed. Not only is the data stored in JSON, the queries are in JSON, the update operators are in JSON. You'll see in a minute, that's going to be great when you're in a world where you are talking REST to everything, and there's JSON flying around all the time. That's the reality of mobile. So the fact that MongoDB in your data store natively thinks about everything as JSON is really good. I'll show you in a minute, geospatial indexing built in. So you can tag things with latitude, longitude coordinates, and search within a bounding box, a circle. I'll show you. It's really great. And then, the last thing is GridFS. This is MongoDB's distributed file system built into the database. So this is like how you'd implement YouTube, for example. And I'll show you that. It's good for mobile because mobile often has media flying around. Okay, geospatial indexing. Let me talk about this for a sec. Like I mentioned, you can index on latitude, longitude pairs, and then you can do searching by a bounding box or searching by a bounding circle. Here's an example. So in our post, if we had a field called loc or location, you can place an index on location. You can then do 3 types of searches. This would basically show me the 10 closest things to this point. So show me the 10 closest places in the database to the point 50-50. And I don't actually really know where 50-50 is, but it's somewhere. And similarly, this is how you would say, get me all the places in the database that are within the bounding box specified by this rectangle. And I think it's lower left corner, upper right corner. Similarly, circle, point and radius. Give it a point and a radius. It'll tell you everything within there. Great use case, actually. Foursquare uses MongoDB for all their geo stuff, for most of their geo stuff. Their whole Who's Here service, that's where they track everyone for the last 3 hours. Exclusively Mongo. All the check-ins, tips, and venues are written to Mongo. They're still migrating from a legacy Postgres system, but from what I hear, they're almost done, and they're loving it. GridFS, this is the file store I was telling you about. Basically, inside the database, obviously you can store those JSON documents. You could also just throw these large files in there with metadata, and just like you would, the JSON documents. And if you do have clustering going on, it will, it'll take you. For example, let's say you were to put, 2-hour-long video in there. It'll chop it up and make sure it's chunked. Also works well behind a CDN. I've never done this personally, but supposedly you can do that. So yeah, this slide here, I just wanted to show you guys. This is the cool list of customers. The point here is just that it's got some good production mileage on it. So that's how you get bugs out of your system. That's how you make things production ready, is by having people use it and find all the ways in which it's buggy. So it's got some good street cred. It's got some good production mileage on it. And that's really all I need to say there. Great question. Okay, so the question was, are the indexes for all the data stored in memory? No, so the indexes are stored on disk. The way MongoDB is implemented is it uses memory map files. So the idea is actually when you create a MongoDB instance, you do want to try to use enough RAM so that the indexes can, when it's running, the indexes can be in RAM. And basically that's handled by just the way the operating system pages back and forth between real memory and virtual memory. So the rule of thumb is, on sizing, for example, so it's all stored, persistently. It will kind of page up into RAM, as it's used, as the OS pages it in, because the indexes will be used a lot if you're searching on them. And the idea is to keep at least, ideally all your indexes, but at least your working set of indexes. So for example, you might only be searching the last 3 months. So you can have the last 3 months of indexes in there. Oh yeah, so I just wanted to say, it's not a panacea. There are things that you don't use MongoDB for. Like I was mentioning before, multi-operation transactions. So if you want to say, look up this thing, then delete it, then update this record, and oh, whoops, roll it all back, like none of it ever happened, this is not your tool. The other time is when you really, really need joins. And what I say by really need joins is I really mean you need the power of being able to do Cartesian products of tables. Not joins just to follow a foreign key, because you can do that kind of thing here, but where you really need to have the relational algebra power of joins. And sometimes you do, and that's fine. But often I'll just say this, often in the web, you're crawling a tree of information. Right? You're saying, look up this thing, and then, oh, there's some stuff, and then here's the idea of this other thing I want to look up because the user just clicked on it. Oh, let me look up that thing. Right? And so for that type of thing, Mongo has been great. the question was, is there the idea of a key, and I'm reading into your question a unique key, and a key by which you reference other things. So every single MongoDB document gets an underscore ID. You can give it an underscore ID when you create it. So you can name things however you want. If you don't, one will be generated for you. And it will be generated as a unique key. Most of it, by default, there's a unique index on that. But you can turn that off if you really want to. Convention has folks pointing to other documents via ID, but you don't have to. I've seen examples where people use a more natural key, like a name, even though there's a dumb auto-generated ID behind the scenes. The question is, can you choose what fields to index on? Yes. So you can index on any field. You can, and it's really great. So you can index on author. I could index on author.email. Okay. I could index on, where's another good one? Obviously, we saw I can index on the location. I can also index on, where was it? I can index on tags, which is really cool. So they call it multi-indexes. So politics would be a key. So this would be indexed by politics and Virginia, for example. So, and just one other thing. So you do the indexes to make the queries fast. But one of the cool things is you don't have to index to do your queries. Some of the other NoSQL key value stores out there, if you don't kind of ahead of time know how you want to query the thing, you can't do those queries. This allows you to do ad hoc queries. They might be slow. You add the index, and then it's fast.